Good morning. This is a video where I go through some intermediate maths challenge questions, questions 1 to 10, of the 2017 paper, which is in the description below if you'd like to have a go at it. All of this property is obviously owned by the Intermediate Maths Challenge, and I'm hoping that the UK Mathematics Challenge won't mind me sharing the paper and sharing how to do these things, but more can be found out from their website. What I'm going to be doing is working through these questions, showing you some techniques, and hopefully this will help you to see how you go about math challenge questions, how they're a bit different from the maths we do in class, and giving you sort of a heads up and maybe reassuring you that you do know what you're talking about. So, here goes. I am going to go straight in when we start into questions 1 and 2. At any point, feel free to pause the video, have a go at the questions yourself, and then see how I would do it. So every time I go through it, I'll leave a small pause at the end and at the start of each set of 2 questions. This allows you to pause and do it in your own time. So here goes with the first 2 questions. As you can see, it says, what is the value of 2/5 plus 2/10 plus 2/500? So the first thing I'm going to do is I'm going to turn all of these into 500ths. Because when we add, we always want them to be 500ths and always have the same denominator. As soon as I've done that, hopefully it should be very obvious that it's 222, lots of over 500, which if you want to make it over 1,000, we double everything, is 444, which is why the answer is 0.444, and that is answer D. Question 2 says, in each of these diagrams below, it shows a circle and 4 small squares. In each case, the centre of the circle is the point where all 4 squares meet. In one of the diagrams, exactly 1/3 of the circle is shaded. Which one? Well, the first thing I'm going to do is realise that 1/3 of 360 degrees is 120 degrees. So I can immediately eliminate the 90 degrees one and the 180 degrees. In fact, we know that half of a square, because we know that that's 90, is going to be 45. But we know that 120 is 90 plus 30. So therefore it's not going to be the one that's 45, so it's not going to be the exact halfway one. So therefore it's either this one or this one, B or D. But B is the one that's smaller and this one's bigger. So we're going to say that that's going to be 60 extra and that's going to be 30 extra, and we want the one that's 90 plus 30, so it must be answer B. If you want to check your answers, feel free to pause it now. If not, I'm going to move on to questions 3 and 4. How many squares have 7 as their units digit? So, square numbers always are made, even if we had something, for example, like 17 times 17, the units digit comes from the 7 times 7. So, we can check all of them exhaustively. 1 up to 9. In fact, I'm even going to include 0 because they're the only things a number can end in. 0 times 0 is going to be 0, so that's a possible ending. And all of these square numbers, if we check them all out, we will then be able to say, well, how many possible endings are 7? And it's quite weird because we find out that it's 1, 4, 9, 6, because it's 16, but the ending is 6. Probably shouldn't put an equals there. 5 is going to give us the ending 5 because of 25, 36, 49, 64, and 81. Will you look at that? It goes 1, 4, 9, 6, 5, 6, 9, 4, 1. It's like it repeats itself. There is no way of making 7 as the units digit, so therefore it's 0. In question 4, we ask, which of the following is not the sum of 2 primes? So to help me, I immediately list the prime numbers. And then I notice that, well, 2 and 3 makes 5. So we know we can do that one. 2 and 5 makes 7. So we know we can do that one. 2 and 7 makes 9. So we know we can do that one. And I can't do 11, but I can do, excuse me, typical sneezing in the middle of a video. 2 plus 11 is 13. So we can do that one. That means the only one that can't be done is D. Again, a small moment to pause if you need to. If not, I'll move on. The diagram below, to the right even, shows two circles with the same centre. The radius of the outer circle is twice the radius of the inner circle. The region between the inner circle and outer circle is divided into 6 equal segments. What fraction of the area of the outer circle is shaded? Now these questions are simpler than they look, because what I normally do is I will turn this question into a question about some different circles. And let me copy that circle and do a slightly smaller one, so the inside circle, and I might have to draw the other bit. So the ring is the bit round the outside. Now, this is what I think is the most efficient way to do it, is deal with each question separately. So I'm going to call that 2r and that r. I did that because it says the outer circle is twice the radius of the inner one. So if I just call that one r, then the outer one is going to be 2r. That means that I can then use area equals 2r pi r squared times pi. But remembering to keep the 2r in a bracket, so it's going to be pi times 4r squared. And this one is going to be just pi r squared, the definition. That means the ring that's left is take them away, and we get 3 pi r squared, because 4 take away one of them. But we only want the shaded bit to be half of that, because we only want 3 of the 6 sections to be done. So I'm going to divide it by 2. It then says the fraction of the area of the outer circle. Well, we've already said the area of the outer circle is 4 pi r squared. So we're going to do a fraction of 3 pi r squared over 2 divided by 4 pi r squared. Now the interesting thing about this is that the r squareds will cancel, the pi will cancel. We've now just got 3 over 2 divided by 4, which is 3 over 8. You can always divide by a number by multiplying the denominator by that amount. So then 3/8, which is answer B. When doing number 6, first thing I do is find the total of the ratios. 3 plus 4 plus 5 plus 6. 3, 4, 5 and 6 adds to make 18. We then divide 360 by 18 and we get 20 degrees. So therefore, each of these are going to be multiplied by 20. So we've got 60, 80, 100, 120. And it says what's the difference between the largest and smallest. There's the largest, there's the smallest. So we've now got 60 degrees. Now anyone wondering why I divided 360, it's a quadrilateral, and angles in a quadrilateral always add up to 360. So we just shared it into its 18 bits, and then it must be a 60 degree difference. So it's answer D. Moving on. 4 different positive integers are chosen, so they have a mean of 2017. Now, we'd love to just use 2017. Problem is, to be the mean average, we needed to be able to divide it by something. So I think, in order to be central, we actually want 2016. We want 2016 and 2018. 2 distinct integers. Remember, integers are whole numbers, and they have a mean of 2017. Then we want to go either side again with different numbers. Again, we want it to multiply, add them all together and divide, so we need them to be the same distance from the middle. And this is the only way we can get this close to 2017 without, obviously we need the balance either side. Each number needs to balance with one on the other side. So therefore it says, what's the range? And that makes the range 4. Answer C. Which of the following numbers is the largest? In order to do this question, I'm going to list them all in my squares. 1.3542. And to help with this, I'm going to add a few more zeros, because it finishes, so we can always add zeros. 1.354, and then just the 2's repeat. Now, if you didn't know this already, for C, the dots over the 4 and 2 means that when we get to the 4, 2, we do 4, 2, 4, 2, 4, 2, etc. I know this goes on. All of these go on. 1.3542, 542, 542, etc. Because it's all 3 bits repeat. And finally, it's 1.3542, 3542, etc. That should make it, they're the same, they're the same, they're the same, they're the same. But this one, the 5 beats the 4, 3, 2 and 0 into being the highest. Therefore, D is our highest answer. Little pause. And then finally, questions 9 and 10. The number TU is the 2-digit number with the units digit of U and the tens digit T. So what I do when I look at this, if TU was, say, 21, T would be equal 2, U would equal 1, but 21 would be 2 tens plus 1. So I think TU is actually can be better written as 10T plus U. This is helpful when we're doing AB. AB can be rewritten as 10A plus B, and BA can therefore be written as 10B plus A. Tens are 10 of them, and then ones of the units. If we now do AB to take away BA, we're doing 10A plus B minus 10B plus A. Remembering to take away both bits, that ends up with 9A minus 9B, because B, take away 10 of them, is 9B. We can even factorise that as 9 lots of A minus B. We're told that they are distinct, so they're different from each other, and they're non-zero. So it's basically saying, what's the largest possible value where you can put a digit into this equation and get the largest value? Well, that's got to happen when it's the biggest number. So we want that to be a 9, that to be a 1, because we want the biggest number possible. 9 take 1 is 8, so I think 9 eighths are 72, because the biggest possible thing is 9 and the smallest possible thing is 1, so we can get an 8, and it's 72, which is one of the answers. That leads us to the last thing we've got to do, which is question 10, and it's just an angles in angles around a point problem. Because we're told they're rectangles, the first thing I'm going to do is put some squares in here to show that we know these angles. Then I've just got a series of questions to do. 43 and 90 makes 133, and to make it up to 180, that means 47 is missing. It's a straight line, so it must be 180. Then we've got 29 plus 90 is 117. That leaves 63. Now we've got a triangle, so we're going to need to be what's left over from 47 and 63 is 110, leaving 70. First of all, I will make sure that I can add up properly. 29 plus 90 is 119, leaving 61. Let's make sure we can do maths. 61 and 43 is 108. Let's do some rubbing out just to make sure we haven't got silly mistakes. So, good job I spotted that in time. We've got 119 and 61. So 61 is 108. Then that leaves 72 as this angle here. And we've now got 72, 90 and 90. And that should add up to 360 around a point. But it doesn't. We're short by 108 again. 118. 108. So we've got our 90s. We're short by 108 again. So it would be 360, 252. And so we're short by 108. So X must equal the 108 that's missing, which is answer A. Okay, that is how we go about the first 10. I encourage you to have a go at the other 15 questions. I will try and record a video in the next week or so where you get to see how those ones work as well. But this should be something to take forwards. See how I've gone about the questions. I've broken them down. I've not tried to do them all in one go. Broken them down, and you can see I show an awful lot of working out when I'm doing these questions. I don't just try and do it all in my head. It's foolish to. If you rely on storing things in your head, you're using your head for the memory bit and wanting it to do the processing as well. By putting things on the page, you stop using your brain for memory, which means your brain is freed up to be able to do all the processing of the stuff you've got laid out in front of you. It's just a little tip for you. So, I've been Mr. Harris. You haven't. I hope you've enjoyed this video and got something out of it. Take care. Until next time.